Hi everybody. I skipped the fancy introduction page, so we're going right into it here. We're going to start with taking an answer and going back to a factor. So if you think about what happens when you solve a problem, like let's say you get x plus 5, right, as a factor. When you set that equal to 0, you get the opposite. So we want to make sure when you put it back into factor form that you use the opposite. So if x equals 2 is the root, then x minus 2 is the factor. Just like my example, if x minus 5 is the answer, then x plus 5 is the factor. Now you don't have to put that in parentheses necessarily. I'm just doing it because it says factor, and it helps me realize that it's a factor. Now when you have a fraction, if you think about this, you never really factor something and get like x minus 2/3. Like that's not how you factor something. So you don't want the factor to look like that. What happens is you end up with something like this when you factor. A factor that might have a number in front of the x, and then you would set this equal to 0, so we get 3x equals 2, and then divide by 3, and so that's how you get the 2/3. So the pattern is take the denominator and put the letter with the denominator and do the opposite of the numerator. So this would turn into 2x minus 1. And so if we check that, 2x minus 1 equals 0, we get 2x equals 1 and x equals 1/2. So it does work. So again, denominator gets the letter and then opposite of the numerator. So this will be 4x. Just assume this negative sign, I know I put it kind of in the middle, but we want to assign it to the numerator so that we can take the opposite of the top. Don't ever take the opposite of the bottom because we never start with a negative number. Anytime you have a radical, that is not something we really factor. You don't really factor something and end up with a radical, so we're just going to go ahead and write this just like we would if it was a number like 2 or 7. So this will be x minus 3 radical 5. So over here I have a list of just some examples of some polynomials. This is just to help you realize what standard form looks like. Make sure it starts with the highest power and it works its way down, all the way down to the lowest power or no power. Oops. So here we go. Let's write some polynomials. In fact, really anything goes. You might have multiplicity. You're going to obviously have fractions and radicals. So we're going to turn these into factors and then start multiplying. So if x minus 3 or x equals negative 3 is the answer, this would be x plus 3. This one would be x minus 2. And this one is x minus 5. Now we are multiplying, so it doesn't matter which two you multiply. You can't multiply all three. So I'm going to kind of keep that one. I don't know why my hand's so wiggly. I'm going to keep that one kind of over here. I'm not going to use this x plus 3. I'm just going to multiply this stuff. So we get x squared minus 5x minus 2x plus 10. Combine like terms. Every time you multiply, it's going to be easier if you combine like terms before you move on. It is optional, but I would recommend it just to make it a little bit easier. Now we're going to multiply everything by this x plus 3. So I'm going to start with x, and I'm going to just distribute the x to all the parts. So we'll get x to the third minus 7x squared plus 10x. Then I'm going to use the 3 and do the same thing to each piece of the second part. So we have plus 3x squared minus 21x plus 30. This is where the standard form will come in. Right here, if you simplify it and write it in standard form, we can do two things at once. There's only one x to the third. X squared, we have a negative 7 and a positive 3. So that's a minus 4x squared. The x's, looks like we have a 10 and a minus 21. So that's a negative 11x. And then, of course, all we have left is that plus 30. So the answer is in standard form. It doesn't equal anything. You don't have to give it a name. You can just leave the answer alone. So let's switch this to some factors. Minus 7 would be x plus 7. 0. If we have x equals 0, well, then it's just an x. But it has a multiplicity of 2, so that's going to be x squared. And then we have x plus 1. Now, this is kind of messy. The way it's written, we wouldn't have x squared in the middle. I'm just going to rearrange this a little bit, just so it looks a little bit more like what we're used to. And you can multiply this stuff in any way that you want to. I'm going to leave this x squared alone for a second and multiply this out because this looks easier. So we have x squared plus x plus 7x plus 7. Leaving this x squared out there, x squared plus 8x plus 7. So we'll get x to the 4th plus 8x to the 3rd plus 7x squared. Finally, we have one with a fraction. So let's just switch these to factors first and then take a look at maybe we can pick a good order to multiply this in. So we have x plus 2. Remember, it's denominator with the letter opposite of the top. So it's 3x plus 4 and then x minus 2. Now I recognize these two as being easy to multiply together because they're a difference of 2 squares. So I'm going to multiply those two together first, and I'm going to leave this 3x plus 4 kind of out there. This is the difference of 2 squares, so it's simply just x squared minus 4. Use what you know about factoring to help yourself multiply faster. Now also, I'm going to try to multiply this and force the correct order to happen just simply by paying attention. I know this probably gives me my highest power. So this is 3x to the 3rd. Now my next highest power is going to include the x squared, so I'm going to go plus 4x squared. Then inside will give me a minus 12x, and then the negative 4 times the positive 4 is negative 16. So I multiplied it, and it's in standard form. And if I'm paying attention, this is x squared. There's nothing to add or subtract, so it's finished. With the radicals, remember we don't have any kind of special trick. This is going to be x minus the square root of 2, x plus the square root of 2, and then of course the x minus 1. Now what I would recommend on the square roots, if you have 2, multiply them together first always, because that's how you get rid of it. It'll get rid of itself if you have 2 of them. I know you don't always have 2 of them, but if you do that first. So if we think about what this looks like, this is going to be a little strange looking. We have x squared plus x radical 2, right? That's the outside. Inside is a minus x radical 2, and then minus a plain old 2. Square root of 2 times the square root of 2 is the square root of 4. But skip that step because that's unnecessary. If they match, you just get the plain old number. Right? We could take the square root of 101 times the square root of 101. I don't know what 101 times 101 is. I don't care what it is. It's just a plain old 101. So use that kind of knowledge to help you go faster. So now, and this x minus 1 is still here, we have x squared minus 2, because the radicals are opposite and they're gone, times x minus 1. And so again, I'm going to try to multiply this in a smart way so that I don't have to rearrange it. X to the 3rd. And then I'm going to have outside is a minus x squared. Then inside is a minus 2x. And then negative 2 times negative 1 is a positive 2. Imaginaries. Imaginary roots always come in pairs. They have to. That's the only way to get rid of it. Like if you don't see any imaginaries you don't see any i's in these polynomial answers, and you better not, because that means it's wrong. So if 3i is a root, then negative 3i also is a root. They're not always going to tell you that. I don't know why. I don't know if they think they're cute or funny or whatever, but they don't always tell you. And this is problem number 5. And number 5 is also a factor. So sorry if that looks weird. So let's take a look at this one. We have x minus 5, x minus 3i, and x plus 3i. So we got to remember some other things about I. I squared is equal to -1. This is super important, and it's something we'll need here in a minute. If you have things with imaginaries, you have to multiply the imaginaries first. You don't really have a choice. If you don't do it that way, you will get something super messy, and it's not worth it. It's really just not worth it. So multiply the two's imaginaries together. If you don't have two imaginaries, then you're doing something wrong, because they always come in pairs. Opposites, right? So we have a positive 3i, negative 3i. So let's multiply this out. This is going to be weird looking. So we get x squared outside plus 3ix, inside minus 3ix. And then the 2 at the end give you -9i squared. So this x minus 5 is still here, and then we got to clean this up. This is weird looking. So the positive and negative 3ix cancel, thank goodness, because I don't know what to do with that. And I squared is really a -1. So that has to come out, and this is a multiplication problem. So you have to multiply -9 times -1, and we get a positive 9. And then, whoa, sorry, I don't know what's wrong with my hands. So right there, we have no i's. That was the whole point. You're not supposed to have imaginaries. So we know we're doing something good. And then let's multiply these two little things together. So we get x to the third minus 5x squared. Outside is a positive 9x, and then the plain old numbers is a minus 45. It's in standard form. We have no like terms to combine. So I want to go through this one more time. Let's do all the weirdness together. Radicals and imaginaries. It's not difficult. It's just super strange looking. So remember, if -2i is a root, then positive 2i is a root. They're not always going to tell you that. Again, like I said, I'm not sure why it's that way. Just trying to make you pay attention, I guess. So we have x minus 2 radical 5, x plus 2 radical 5, x plus 2i, and x minus 2i. We have to do the imaginaries first. I would really recommend that. So I'm going to split this up like this, and I'm going to multiply these imaginaries first. And I'm going to leave this alone for just time being. We'll get to that in a second. All right, so over here, we kind of already know what's going to happen because they mirror each other. They mimic the same pattern. So we have x squared plus 2ix minus 2ix. So we always know that that's going to be gone. So if you want to skip that, skip it. And just do the first two and the last two. Sorry, we don't really need that one, I guess. So then we're going to have a minus 4i squared. I'm going to multiply these two together now and hang on to that. We'll fix that I squared in a second. So I'm going to have x squared minus 2x radical 5 plus 2x radical 5 minus, now I'm going to go over here. Let's go up here. I'm taking this up here. 2 radical 5 times another 2 radical 5. Whole numbers get multiplied together. That is a 4. Radical 5 times radical 5 gets multiplied together. That is a plain old 5. So this is a 20. So this is going to be minus 20. Over here, we have x squared. I squared is really -1. So we get x squared plus 4. And over here, those add up to 0. We get x squared minus 20. We're going to multiply this by x squared plus 4. If you were to factor this, you would add them in the middle and multiply them at the end. So watch this. X to the 4th. If I add these two numbers together, -20 and a positive 4, that's -16. But it's going to have an x squared after it. And then I'm going to multiply the -20 and the 4, get a -80. That's the fast way. You don't like the fast way? It's too fast? Don't do it. So let's go through this a little differently. We would have x to the 4th plus 4x squared, and then inside minus 20x squared, and then the 20 times the 4 is the -80. And then you can see We add these up, and we get the same thing. So the homework obviously is on the back, and it's much shorter. I just wanted to make sure you saw all the different things that you could run into, and make sure you pay attention to multiplicity. And if you have one that you can't do, just stop when you get to a point that's confusing, and I'll answer your questions in class.